All right, so good morning, everyone. Let's continue our session on Scala. So in the last class, we finished till this point, like your escape characters and all, right? Now we'll start with uses of data types, okay? So let's continue and discuss the data type one by one. We'll start with Boolean, okay? So Boolean, as you know, can be used to represent true and false, nothing else, okay? So true and false. So you can define a Boolean variable like this, where flag equal to true. Okay, or you can say where flag of Boolean type is equal to false. So this concept, this approach is called type inference, where you are really not writing the data type, right? Based on true or false, it understands that this flag should be a Boolean type. Here it is like explicit approach, where you are actually telling that I want to declare a variable called flag of Boolean type, right? And the value we have given it equal to false. This will not work. You cannot say flag, variable flag of Boolean equal to 12. It is a mismatch because 12 is an integer and your flag is of Boolean type. So it expects you to pass true or false. Okay. However, you can also say something like, well, is true is equal to not true. So not true is false. So false will be assigned to is true. Okay. Now you have to be a little careful while you do this, like this command and this command are same. Okay, but what happened is because I did not give a space, it got confused. Okay, so make sure that you have a proper space. Similarly, well is false is equal to not true. So not true is what? False. So this will give you false. Okay. And you can have any expressions here. Like if you see well unequal equal to 5, not equal to 6. This is an expression which will give me either true or false, right? 5 is not equal to 6, true. 5 is really not equal to 6. And you get here true, right? So if you want to do those exercises, so go to command prompt, say Scala. Although I'm giving you access to these videos and documents, but I'll always suggest you that you please carry a piece of paper and pen and just try to write something when I'm explaining this, because it will give you more more better understanding on the subject. Fine. So always carry a piece of paper and pen so that you can quickly write some important observation that will help you to take more from this session. So as I said, where flag equal to true is of Boolean type, and you can also say here Boolean, right? You can say not true, again space problem as I said, so just give a space here. Okay, again try to assign something like 15. Okay, does not work because you should only assign a Boolean result, but I can say 15 is not equal to 15. Okay, it is false. 15 is equal to 15, right? It is false. So likewise, you can use Boolean in this way. Okay, now so see here, what I did is I said unequal, 5 is not equal to 6, true, right? 5 is not equal to 6. So I got unequal, which is basically true. Again, is less, 5 is less than 6, true, right? 5 is less than 6, true. So here I got true, here I got true, right? So the value of unequal and the value of is less is true, right? And then I can create some expression here like unequal and is less. So this is true, this is true. And if you're doing and, then what will happen? It will give you true. True and true is always true, right? True and false is always false. Okay. Similarly, well, definitely false equal to false and unequal. Okay. So here, if you see, I'm using and. So these two are two different operations, right? These two are two different operations. So anyways, we'll talk about that. Okay. So false and unequal. So what is the value of unequal? Unequal value was true. So this is false and I'm saying and true, right? So this will always give you false. Okay, now let's understand what the difference between this and an operator. Okay, so the difference is your your and your or are called as lazy operators or short circuit operators. Okay, whereas this and is basically called as your logical operators. There is a difference, right? So these are basically short circuit operators and they are basically logical operators. Okay, now to understand that, let's take an example. Okay, so yeah, so before I talk about that example, let's understand it a little better. So we just want to understand what is the difference between and uh, and, right? Control Z and, right? So this is basically called as your logical operator and this is called as your short circuit operator. Okay, so when I say this is a logical operator, so I'm sure you might have studied those logical gates, like where you have true, 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 false, false, true, false, false, right? And if you do AND of this, right? So it's like 0 and 0 or 1 and 1, right? So like in logical gates, you used to study 0, 0, 0, 1, 1, 0, 1, 1. Is not it? So 0 and 0 will always produce you 0. And since this is AND operator, right? So this AND operator. Okay. 0 and 1 will always give you 0, right? So it's AND, it's not OR. Yeah. So this will also give you 0 and this will give you 1. Is not it? So this is how your AND operator works. If it would have been 1, sorry, or, then the story would have been different. Like for or, you would have got 0, you would have got here 1, you would have got here 1, you would have got here 1, right? But we are trying to understand how are they different. See, they look little similar as of now. Right? So suppose if I want to do an and, right? So like if I go by true and false, then true will give me true and rest all would give me false. Okay, and that depends on these two operators, right? But if you use and, the result could be little different. Let's understand that. Okay, now what I'll do is I'll just try to like execute one simple example and let's see, let's understand what happened. Before we execute that, okay, so let's try to put them here and let's see if you can answer it correctly. Which I want to do. Okay, so this is what this is what basically I want to do, and let's understand what would be the output of this. Okay, so what we have done is we have a variable x equal to 10. Okay, we have a variable y equal to 20. Well or where, let me call it where, but you understand that these are constant, these are not. Okay, now I have one more number called I have one more variable called num is equal to 5. So far good enough. Now what we will do is, let's say num is greater than less than x. It says num is less than x, right? Num is less than x. So what is the value of num? Num is 5. 5 is less than x. So can you tell me whether this is true or false? This is true. Okay, and what I'm using here, or. Okay, so I'm using here or, right? Or is like similar to your and, right? So I'm using here or. Now tell me one thing. See, this first part gave you true, right? Now true or, okay, anything else in this world will always be true, correct? Right? If I say true and true, it will always be true. If I say true and false, it will always be false. That means if this part, the first part itself is true, then there is really no necessity to execute this logic. Okay, so this logic will not be executed, and that's the reason they are called as short circuit operator, because the first result itself is enough to conclude the final output. Okay, so this will not be executed, and since it was true, so since this was true, so what happened, the whole expression, this if condition would be true. Okay, and it prints you true, and it does not even print false, it just prints you true. So if you see the document, let me go back, so this print me true. Okay, but what is the point I'm trying to make out here is, if you see, in my second condition, I was trying to update my y as well, right? My y was 20 and I was saying y is equal to y plus 1. So y value I was trying to increment to 21. Okay, 20, I was trying to increment to 21, and then I was trying to compare it. Okay, but what happened was this part was not even executed. So y value will still remain 20. Are we clear, guys? Can you type clear if you are clear? Okay. Now this was what, or operator, right? So now what I'll do is, let me replace this or operator by and. Okay, and again this is also a logical operator, the same logical operator. But in case of your and, what do? We basically okay, so let's look into this, right? So in case of your and operator, so see, my condition is same. Okay, so these two lines are written exactly same, except this or, sorry, except this or been replaced with and. Okay, now this was giving me true earlier, correct? Okay, so this was giving me true earlier, but tell me, is this true sufficient enough to derive the whole result? Yes, no? Certainly no, because see, this you got true, but what the guarantee that you'll get here also true, right? Because here you may get false. If you get false, then your result will change. Your result will not be true. Right? So since this was true, we have to, this logic also needs to be executed, because true and false can give you false, right? True and true will always give you true, of course, but what is the guarantee that you'll always get true here? Not necessary. You may get false here, right? And in this case, what will happen is, this will be evaluated to true, and right? This will be evaluated, right? So y value will be incremented from 20 to 21. Done. And y is equal to 21. Yes. So this is also true. This is also true, which means your output will still be true. But if you try to print your y, the y value has incremented to 21. Okay. So here let me print this y. uh, oh, I have not done this. No worries. So let me do it. Okay, and if you see, I will try to print the value of y value is 20. Now the same thing for the second case. Let me try to print the value of y. The y value is 21. Okay, so let me conclude. I'll conclude that. So in like it depends, right? So in or, so let me put up here. So we were talking about and when we were talking about or, right? So see, in case of your or, if I write true, 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 false, false, true, false, false. Okay. Now, what will be the result here? Correct? Yes. Yes or no? So this is my or. In case of my or, true, true. Both the expressions are true, then the final output will be true. True and false, then the outcome is true. False and true, the outcome is still true. False and false, the outcome is false. Now, in this case, right, if you see, if my first expression is true, then my result is same, right? My result is same. Okay, if my first expression is false, then not necessarily that my result will be same. So conclusion is very simple. If I write if expression 1 or expression 2, okay, if I write expression 1 or expression 2, and I'm using here or, okay, in this case, if you're using or, then if first condition can decide the final output, second condition will not be evaluated. Which means if I say this has a condition which will be evaluated to true. So if that condition will be evaluated to true, then there's no point of evaluating expression 2 because I don't care about the result. If it comes true, if it comes false, then also since it is or, this will always give me true. Right? Yes, this is a logical maths. It's not a programming. It's not a big deal, of course. Okay. So similarly, if this is false, if this expression is false, then it has to go and evaluate the second part, right? Because false does not conclude if your final output will be false. Who knows that your expression 2 may come true, and if your second condition comes true, then your if condition will be evaluated to true. Okay, so in case of or, if the first condition is true, then second condition will never be evaluated. That's the point I want to make out of it. So just go to the notes. In or, if the first condition is true, then second condition will not be evaluated. Okay, again, in case of and if first condition is false, so if I say if
Okay, so if I say this is false, right? Now, if this is false, then no matter I get true here or no matter I get false here, my output will always be false. So if you are using AND, so if the first condition itself is false, then the second condition will not be evaluated. Okay, but if this is true, then it has to go back and check the second condition, because true AND you may get false here also. Okay, so it's a simple math. It's something which we were studying in the school days. Okay, now you may say, hey, I want to replace this OR with a single OR. Okay, with the single OR. So if you say this single OR, then what will happen? You know, this and this both will be evaluated, because this is not logical operators. Sorry, this is not a short circuit operators. These are logical operators. So this will also be evaluated. This will also be evaluated. Just check the value of Y. The value of Y became 22 because previous value was 21, right? So in case of your OR, your value gets incremented. Okay, so what I'm trying to tell you is this logical operators will always have both the expression evaluated, irrespective of what is the first value. Okay, whereas the short circuit operators, if the first condition itself is sufficient to decide the complete output, then the second condition will not be evaluated. I hope it is very clear to everybody now. Yes. So I'll put a point here. The logical and OR will have both the condition evaluated. No, see, you need to understand that if you're using logical and logical OR, then both the condition will be evaluated, expression 1 as well as expression 2, right? Irrespective of what value it has given. Okay, they will not short circuit anything, right? But if you're using this short circuit operators, then there is a chance that second condition may not be evaluated if the first condition itself is capable enough to give you the complete output. This is logical OR. This is logical OR. And an OR, the logical OR, what you used to study in mathematics of maybe class 10, those logic gates and all. Okay, and this is what you learn in the computers, in C programming and all. Okay, moving forward. So yeah, so you cannot convert other data types to Boolean. You need to write expression in order to get the result, as I said. So if you have a value called 12, you cannot convert them into Boolean, right? How do you represent, like, how do you say 12 is true or false? So you can maximum, you know, what you can do is write an expression which can evaluate to true and false. Then only it can be assigned to a Boolean variables. Okay. Type inferencing, as we said, the ability to determine the data type based on the expressions, right? So they are called as basically the type inferencing, which we have already discussed. Always prefer using type inferencing instead of explicit typing, since it makes the code short. However, you can use explicit type when you want to make sure your intended data type is assigned. So what I'm saying is, whenever you're writing any Scala production level code, right, never ever write something like this. Say, well, never ever write something like this. Say, well, x of int type is equal to 5. Okay, never write like this. Always, prefer avoiding this. Let it come automatically. Well, x equal to 5. Okay, in the initial days you may write just because you are learning it, right? So you maybe you wanted to be sure that this x will always get integer type value only, and that time you can basically write them explicitly. Otherwise, I will not suggest you to write it explicitly. Always have the Scala decide it for you. Okay, take the benefit of the language what it is offering you. Okay, now let's talk about bytes. Okay, so as you know, byte means it can just store the data of 8 bits, right? And the range is -128 to +127, right? So let's try to store a byte variable, right? So okay, so see now if you see this example here, I wanted to store 10 into a byte variable. Here type inferencing is required. I mean, explicit typing is required, because if you don't do so, then by default it will treat that x is of integer type, right? So either you can do it like this, like if you just remove this x equal to byte, then by default this 10 will be treated as integer, right? And how do you basically get the byte, right? So you cannot get the byte. So you can say, well, x should be a byte type, and then you say 10. Then what will happen is this 10 will be assigned to a variable called x, and x variable would be of byte type. Okay, you can also do something like this, like on this 10, try to see if there is something called 2 byte. Is there anything? Yes, right? So if you do so, then what will happen is this will be converted to a byte, and this byte will be assigned to this x. Okay, so look into this. I created a variable called x with the value of 10, right? And then I'm creating another value called y with the value of 20. So let me do this way, 2 byte. This will also give you a byte variable only. Okay, so we got byte 20. So we have x and y, both are of byte type. Now, every arithmetic operation that you perform will always return you an integer. So if I say, well, z equal to x plus y. Okay, so well, z equal to x plus y. If you see x plus y, when you are trying to see, ideally you are trying to add 2 byte numbers, right? And it should basically give you byte, right? But what it has given you is integer. Okay, so every arithmetic operations by default will give you an integer. Okay, if you're doing it on the integer types, we're doing it on float types, then the story is different. But if you're doing it on the integer type, then no matter whether it is a byte or whether it is a sort, it will always give an integer. Okay, so now what should we do, right? So what we can do is, we can do something like this. I can say, you add both of them. I know that you are going to get integer, and then you give me byte, right? So this gives me 30 of byte type, not integer type. Okay, now let's see something else what I was trying to do here. So see what we have done. When we said x plus y, it gave me integer, right? When I said x plus y, it gave me what? Integer. Then what I did is I use this plus like a method. Okay, so I said x dot plus of y. So what does it give me? It gives me 10 plus 20, it gives me 30 of integer type. Okay, to be very clear, of integer type. On that I have said dot 2 byte. So ideally, if you see, this line and this line does the same thing, right? So x plus of y, so you just remove this byte and you will see that it will give you integer, right? So this will give you an integer, this will also give you an integer, only this will also give you an integer. So ideally I'm doing the same thing. On it I'm calling 2 byte, so it gives me a byte now. Okay, now you may try doing something like this. You may try doing something like this. X plus y dot 2 byte. See, y is already a byte. You are calling 2 byte, which will do nothing, right? Basically, because y is already a byte. So you're saying dot byte. So you still get y of dot byte. It is equivalent to not writing this 2 byte. Okay. And then you're saying x plus y. So what I'm trying to explain you is you simply missed a simple parenthesis. You simply missed a simple parenthesis and you may assume that you get a byte type. No. What happened is y was byte, got converted to byte again. That's okay. And then x was byte, right? Byte plus byte. So since it is a plus operation, this will return you back an integer. So you got back an integer. So what you missed is a simple bracket here. A simple bracket. Because you're actually supposed to call this 2 byte on the whole result. Okay, now this also does not work. Why will it not work? Because x plus y will always return you an integer, and you are trying to type, like you are trying to say, hey, I want this data to be a byte type only, right? It's not possible unless you don't explicitly, convert them. X plus y will always give you integer, and integer cannot be converted to byte directly, right? So that's the reason it fails. Okay, so how do I come around this problem, right? So you can do something like this as we discussed, like you can say x plus y dot 2 byte. So what will happen? X plus y will be added, 10 plus 20 would be 30. And since it is a plus operator, this is 30 of integer type on which I'm calling 2 byte, which gives me a byte type, and I get the value of 30 being assigned to z, and z is a byte type. This is one approach. The other way would be, you can say vel z equal to x plus y, and then you can use as instance of to convert this integer to byte. Okay, this will also give you the same output. Okay, and as you all know that byte can hold maximum number between minus 128 to 127. This is what we have studied, right? So a byte can hold, the range of the byte is 8 bits, and 8 bits, the formula would be minus 2 to the power 7 to plus 2 to the power 7 minus 1, as discussed in yesterday's class. So that comes to minus 128 to 127. Okay, which means I can write something like this: vel x of byte type equal to 127. Okay, but I cannot really write, I'm really not supposed to write vel x of byte equal to 128 because this is going out of your range. Okay, let's see what happens. Vel x of byte is equal to 127. Okay, let me write 128. Right, so it says type mismatched, found is integer and required is byte. Okay, now, but what I can do is I can do something like this. I can do something like this. See, this was not working. This was not working, right? Because 128 is out of range. Okay. But if I say 128 2 byte, I got minus 128. Okay. Now, to understand that, like how did it go to the negative value, right? So see, byte range is minus 128 to 127. Okay. Now assume you have a clock, a big wall clock, right? So what you have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then 1 here. Okay. So assume that you are, like right now at 9. After 9, you get 10. After 10, you get 11. After 11, you get 12. After 12, you don't get 13, right? You get back the old number. After 12, you get 1, right? So 12 plus 1 will give you 1. 12 plus 2 will give you 2. 12 plus 3 will give you 3. 12 plus 4 will give you 4, and so on, right? So similarly, if it is 1, before 1, what was there? Not 0, but 12. Okay. Similarly, you can put all these numbers in a circle. Put all these numbers in a circle. Okay. So it starts with 0, 1, 2, 3, 4, dot, 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 and it comes till 127. Okay. And again, from here, minus 1, minus 2, minus 3, minus 4, dot, 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 dot. Where does it end? It ends 128. Right? So this is how your bytes are represented. Okay. Now, if I'm in 127, if I add one more number, that means actually 128, but there's no positive 128 number. So 128 is how much? 127 plus 1, right? So if I'm in 127 and if I go one step forward, what will I get? Minus 128. And this is what you are getting here. This is what you are getting here. When I said 128, I got minus 128. Okay. So let me put some more numbers here. Say minus 127, minus 126, minus 125, minus 124. Okay. So now if I say 129, if I say 129, right? I'm trying to represent 129 in a byte by saying 2 bytes, but I don't have 129. So what do you think, what would be the output here? Okay, let's see. Minus 127. Similarly, if I do 25, then sorry, 35, then I got minus 121. Okay. All right. So this is how the cycle works, right? This is how your cycle works. Okay. Now, yeah. So we just explored this part, right? So let's move on. So if I say, well, x is equal to 127.2 byte, I get 127. If I say, well, y of byte type equal to 127, I still get 127. If I say x plus y, I add both of them. And then if I say dot 2 byte, I'm getting minus 2. Why I'm getting minus 2? Because 127 and 127 is 254. and 254 is out of my range. 254 is out of my range, so it will land somewhere, right? It will land somewhere and it will give me -2 with the same formula. Okay. Now similarly, if I say, well, x equal to 128, this is an integer. I can convert this integer to byte and I get -128 because of that cycle. Okay, but there is a formula to calculate that cycle. Okay, there is a formula to calculate the cycle. Let's understand this formula. So I remember one of my instructor taught me this formula when I was learning C programming, maybe 9 + 4, 12 years ago. Yeah, 12, 13 years ago. Okay. So the formula is very simple. Suppose I want to convert this 500 to byte. Okay, 500 to byte. I don't know what is the answer. What is the result I'll get, right? So 500 to byte, I'll get -12. Okay, but like if somebody asks you 500.2 byte, how much will it be, right? You don't know, right? So let's understand how much it would be, right? So the formula is very simple. Check it out here. Formula is, if my number, see, if my number is in this range, if my numbers is in the range of -128 to 127, then the new value will always be n, right? If I say 1, then 1 falls between these two ranges and the value would be 1. If I say 10, then 10 falls in this range and the value would be 10. Okay, but if my number is like greater than 128, okay, greater than or equal to 128, right? So in my case, 500 is greater than equal to 128. Now the formula would be n modulo 256 minus 256. Okay, so 500 modulo 256 minus 256. So 500 modulo 256 will give me 244. Okay, and minus 256 will give me -12. So the result is -12. Okay, similarly, if there are any negative number like -1500, so I'm saying if n is less than equal to -128, 129, okay, if I'm dealing with negative number, then the new value would be n modulo 256 plus 256. So -1500 modulo 256 plus 256 will give you -220 plus 256 will give you 36. Okay, likewise you can count if I give you any problem to solve. For example, just now I asked you how much will 130, where is 135? Yeah, I asked you this question, right? Like how much would be the 135 come down to, right? So if we go by this example, 135, I can see it is giving me -121, right? So if I want to go by that formula, so look into this formula. The formula says 135 comes to the second category, right? So it is n modulo 256 minus 256. N modulo 256 minus 256. Okay, so 135 modulo 256, how much? 135 only. Okay, from here I am saying -256. 1, 2, 1. And this is what you got. Simple formula, right? Okay, so that's how it works, right? So if you want to calculate, like this is the formula which can help you to calculate the final output, what you will get if the number is exceeding your ranges. Okay, this is applicable to your integers as well. Okay, same logic. All right, now let's talk about what the difference between 2 byte and as instance of. Okay, so there are many two XXX method, like 2 byte, 2 integer, 2 float, and so on, which can be used to convert data from one type to another type, right? For example, I have integer. How do I convert it into float, or how do I convert it into byte, right? So there are 2 bytes, 2 integer, and other methods might be available. So we'll just have to check, right? So if I say 10 dot 2 and hit a tab, let's see what all we have. We have a lot of 2 methods: 2 byte, 2 char, 2 double, 2 float, 2 x string, 2 int long, and so on. Okay, so there are so many 2x methods which can be used to convert data from one type to another type. As instance of is a method which is present in any class, your super class, which we are talking about yesterday, and is used to typecast any object to any other compatible objects. Okay, so see, as instance of can be used if you want to convert one type to another type, and if both the types are compatible. Okay, if both the types are not compatible, then it will throw you a class cast exception. Okay, what I'm trying to say is, if I have 10, okay, so this 10 is an integer, right? I want to convert it into byte. So can you tell me, integer and byte, are they compatible or they are not compatible? They are compatible, right? Because they are all integer numbers. Yeah, but see, it is an integer data, right? So if it does not come to a limit, then it will, follow this pattern of clock. Okay, so they are compatible because both of them are numbers. So in this case, you can easily use as instance of. Okay, because they are compatible. Okay, and that means if I want to convert my integer to byte, I have two options. Okay, either to use two methods or to use as instance of method, because both of them are compatible. Okay, however, if I have, let's say, employee1, employee class, okay, and I have something called string class. So can you tell me, are these two compatible types? Certainly no. Right? So if you try to do as instance of, then since these two are not compatible type, you will get class cast exception. You'll get class cast exception because you are trying to deal with uncompatible types. Okay, so my conclusion is very simple. If you have an integer called 10 and you just say dot to press tab, if you see there are methods available that can convert this to byte or float or whatever you want, then please go ahead and use this as a first choice. Okay, because you will not have a problem of checking the compatibility issues. Okay, however, it is not possible to have two methods every time, right? So if you're dealing with classes like employees and department or any real-time classes, whatever you create, so that time, if you feel that there is a parent and child relationship, and if you want to convert them, if you want to cast them out, you can. For example, say I have employee class, and there is one more class called, let's say, engineers, right? So employee is a class and engineer is a child class. So if you have engineer and if you want to convert this integer engineer to employee or and so on, you can proceed with that. Okay, so idea is very simple. Use always two methods if you see them available. If you do not see them available, then give a try with your as instance of. But as I said, as instance of will work perfectly well only if both the classes are of compatible type. Okay, let's look into one such code to understand this. Okay, let's see the below code. Now what I'm doing is I'm trying to create a value 10, right? I'm trying to create a variable which can hold a value 10. Okay, but here what I did is I did not write it should be of integer type. I wrote it should be of any type. Is that wrong? It is not wrong, right? You should not do that because 10 is an integer. You should always assign it to an integer. But this is also not wrong. What I've done is I've assigned this to a parent class, right? Any class. Okay. Now what I can do is I can do something like this. So I can say it if num is instance of int, which means this number, whatever value I am holding, is it compatible with integer type? If yes, then you convert this num to integer type and multiply by 2. Okay, so what happened is I converted this into integer and multiplied by 2. Okay, and then I got a value of 20. Okay, so see here you got any well. The reason is because this if condition does not have else. Okay, I could have written it like this, else 0. See the output. Right, so the output is now integer. Here why the output came any well, because there was only if condition, there was no else condition for that. Okay, so that's how it works, right? So yeah, so let's move on. So if num dot is instance of int, then num dot as instance of it. So what I'm doing is I'm trying to first check, are they compatible? Yes, they are compatible. Then you do the conversion. Okay, but let me try doing something like this. Let me try doing something like this. So what happened here? Let's see. So see, if num is instance of int, true. Okay, so if it is true, then I'm asking to execute this part. But can you tell me what is the type of this num? Is it integer or something else? It's of any type, right? It's of any type. And in that any class, there's nothing called a toInt method. There's nothing called toInt method. So you cannot call it here. Are you getting me? So each instance of can be used anywhere because they are coming from parent. It will throw you a beautiful error if you are trying to do conversion in the incompatible types. Okay, so this toInt method is present somewhere else, but not in any. And that's the reason you are not allowed to use toInt everywhere. You cannot use this toXXX method everywhere. You have to check whether the object on which you're trying to invoke, do you have a toInt method in that class? Okay, so in this above example, what we understood is instance of is used to check whether num is compatible with integer or not. If yes, then as instance of can be used to convert, to get the integer value from your num type. Okay, as instance of is present in your any class, the main parent class, so you can use them everywhere, right? But as I said, be very much aware, if you are not passing the compatible types, you'll get an error. Okay, toInt method can be used only in certain cases where you have such methods. So yeah, so let's move on and let's talk about characters now. Okay, so characters are basically I'll say a Unicode numbers, a Unicode characters, which basically you can store, right? For example, let's say I want to store a symbol A, right? So you can use a character type, right? So let's go with an example. Variable C equal to A. So what we have done, we have stored a character called A in C. Okay, so when you say C of character equal to A, like if you see the C is holding internally A. Okay, now we will also do something like this, where I is equal to C. So what I'm doing is, again, this will assign the value of A back to your I. So I also contains A, right? Now similarly, you can also do something like this. I have got C as A, but if you understand, like every characters has a Unicode. Okay, every character has a Unicode, and Unicode of A is 65. Okay, Unicode of A is 65. So if you say variable j of int equal to C, then what will happen is this C is actually holding A, right? So, and this A is nothing but 65. So j will get the value of 65. Okay, similarly, I can also do something like this. Well, j colon character equal to 97. 97 is the Unicode of small a. Okay, so if you see here, I'm trying to define a j of character type, but what I give is number. I did not give a, I gave number. So if I give a number, then what will happen is its character equivalent will be assigned here. Okay, so what I'm trying to tell you is you could have done it like this. Instead of writing a, if you write 65, then it is an integer, right? But if I say this C should be of char type, sorry, this C should be of char type, then you get A. Okay, so long story short, what I'm trying to tell you is characters are internally integers. Okay, characters are internally integers, and those integers are basically the Unicode number of the characters. Okay, so you can just Google it out, you'll find the Unicode values of all the characters, possible characters, and then you'll see that capital A Unicode is 65, small a Unicode is 97. Okay, so what we studied was, say, character can be used to store certain characters A, B, right? In programming world, you may say if choice is equal to yes, right? Then do something else, do something else. right? So this y is basically what? A character, a simple character. Now you can define this character like user choice, well user choice is equal to single quote y, or take it from the input, whatever works for you. Okay, but the story is very simple. Every character a, b, c, d, or a, b, c, c, d, or 1, 2, 3, 4, or every character has greater than, less than, anything. Okay, they all have a Unicode, a number. For capital A it is 65, for small a it is 97. Okay, so you can also do something like this. See here, what I'll do is I'll say for or let me do it like this. I'll say 65. I'll do it like this: 1 200 dot for each num println num dot to char. Let's try. Now see here, what I did is I was just trying to print from 1 to 100 all the characters, right? So if you see, there are some question mark, which means my system is not supporting those characters possible. Okay, so if you want to make it a little precise, you can say from 65 to 75, 85, 90, let's say 90, or let's say 89. Okay, so if you see, you got A to W, X, Y, Z. Let me put till 100. Yeah, so till Z it is like this, right? So 100, right? So 1 2 3 4 5. So see this output, this is a for each, right? So for each, yeah, so this would give you the correct output. And let me do it this way. 97 starts there, right? So 90, 91, or 92 maybe. Okay, so see this output, like sometimes it gives you the output from the buffer. So all you can do is make it a little bigger, or remove your println and replace it with print, so that you get everything all together. So if you see, we are able to print A to Z, right? So 92, so that means more two less numbers, 90. Right? So you got all the numbers from A to Z. And if you see, this clearly proves that 65 is basically the Unicode of A, and 90 is basically the Unicode of Z. Okay, so let me put something like this. Yeah, so it is just giving me a warning that you use interpolation technique, which we will study later, but for now that's okay, you can just stick to it. Let me have them here. Okay, so 65 to 90, when you try to print, then you get A to Z like this, which clearly says that the Unicodes are like this. Okay, let's move on. So now we'll talk about integers. So any whole number is by default treated as integer if it falls within the range. For example, vel x of int is equal to 10. So this 10 is an integer, right? Again, vel x of int is equal to 0x12. So what I've done is I've written this in hexadecimal format, okay? And this hexadecimal format eventually will evaluate to 18. Okay, so let's give it a try. So Control L, Control U. Now if I say vel x equal to 10, this is integer, right? Again, if you want to say int here, that's fine. So again, if I say xl is equal to 0 into 12. Okay, so these are also integer, and then its value is basically what? 18. How it comes 18? It's very simple. 0x12, 0x12, right? So what do you do? 1 and 2. It's octal format. 8 to the power 0, 8 to the power 1. Right? So hold on. This was octal or hexadecimal? This is hexadecimal. Sorry, this is hexadecimal. Octal starts with O. This is hexadecimal. So if it is hexadecimal, then it is 16. Okay, let me write it again. 1 and 2 into 16 to the power 0, 16 to the power 1. 16 to the power 1 is 16 plus this is 16 to the power 0 is 1. Anything to the power 0 is 1. 2 into 1 is 2. So this gives you 18. Okay. Now moving forward, vel x of int equal to a. So what is this? This is basically a character, right? 65. So I'm trying to assign 65 to a. Okay. Again, vel x of int equal to 0, 1, 2. This is octal. This is octal. Okay. This is an octal number. So when you say 12, this is giving you 12. How come? Because sorry, 0, 1, 2, right? So 12. So if I say it is octal, then it would be 8 to the power 0, 8 to the power 1, right? So 8 to the power 1 is how much? 8. 8 to the power 0 is 1, and 2 into 1 is 2, so it's 10. Okay, now this used to like give me error in the previous versions, and that's the reason I wrote that this gives you a error. Hold on, this is 0. This should not be. This is 0. Yeah. So this used to give me error earlier. Maybe they might have they might have done some improvement on it. 1 minute, guys. 0, 1, 2 should give me 10, right? If it is octal, it should give me 10. Yeah, so 12, this should give me 10, right? So 8 into 1, 8 plus 2, 10. This should give me 10. What did we get? We got 12, right? Yeah. So I think this has not been treated as a 12. So in the previous version, this used to give you an error, okay, saying that, hey, you are trying to use it in octal format, but this is really not octal. This is a number, okay? And then hold on, let me just see if I say this should not work, right? Yeah. So in the previous approach, this 0 used to represent as octal, but maybe in this version onwards, they have, this was already absolute, right? So they have removed this approach, right? And then they are just, I think they are just, ignoring this 0 and they're just making it 12. So let me try with some other number, 1, 2, 3. If it is giving me same 1, 2, 3, then yeah. So this is not an octal. So this is just treated as a normal integer, okay? So if but you know, this approach was not working earlier also. Okay, so if you want to really convert them into octal, now the approach can be this. Okay, so see, 12 of 8, now it gives you what? 10, because 8 to the power 0 is 1, plus, you know, into 2 is 2, and then the first part is 8 to the power 1 is 8, so 8 plus 2 is 10. Again, if I say 1 2 3, this will not give me the same 1 2 3, it will give me some other value, 83. Okay, 123, it gave me 83. So how does it come? 123, right? So 8 to the power 0, 8 to the power 1, 8 to the power 2. 8 to the power 0 is 1. So this will be 1 into 3 equal to 3. 8 to the power 1 is 1. So, sorry, 8 to the power 1 is 8. 8 into 2 is 16. Okay, 8 to the power 2 is 8 into 8, 64. 64 into 1, 64. So 64 plus 10 is 74. Plus 6 is 80. Plus 3 is 83. Okay, so let me just update this document 012. I'll remove this because they are no more valid. Okay, so this is how it is, right? So in the last batch, when I was executing this, it was still giving me the same error, but this time they have removed this error concept, and then they said, let us treat it as a simple integer. Okay, now again, if you see this, I'm trying to, yeah, I mean, it is a decimal, means I'm talking about integer. I'm talking about integer. Yeah, I'm talking about integer. So let me write integer, because you get confused. Because if you talk about the numbering system, there's nothing called integer, right? It's decimal, hexadecimal, and so on. Okay, now moving forward, so let's look into this. Like I'm trying to store a large number. Okay, I'm trying to store a large number in a value in a variable called x. Okay, so this, see, whenever you say, well, x equal to something, by default it will be treated as an integer. Okay, and if you provide a very large value, then it will say integer number is too large. Okay, so if you feel that this can be, you know, like you can store this value in a long variable, then you can simply put L. You can simply put L. Small l will work, but ideally you should always use capital L. Okay, so what it says is lowercase l for long is not recommended, because it is easy to confuse with numeral 1. Use uppercase instead, because see, when you just say L, or when you say this L looks like 1, right? So you may get confused, and that's the reason it is suggested that you use capital L, not the small l. Okay, so yeah, so you can do it this way. Okay, but now this value will be of x, would be of long type, no more integer, right? Because you are converting it into a long format. Okay, now dividing by 0. So if you say, well, x equal to 10 by 0, this will always give you arithmetic exception, as you have seen in Java. In Java also this works in the same way. Okay, now let's talk about float. Okay, so float by default, if you just write 5.0, then they will not be treated as float, they will be treated as a decimal, sorry, a double. Okay, so If you say, well, x equal to 5.0, by default it is treated as double. If you want this to be treated as float, then you should write 5.0f or 5f, small f or capital F. You can use both. Okay, so let me also specify here, avoid small l. Use l. Okay, so yeah, so if you're directly dealing with the decimal numbers 5.0, by default they are always double. If you want them to be treated as a float, then you have to explicitly tell f or capital F, or see if there are two triplex method to convert this double into a float or not, right? So I can write like this, well, v equal to 5, this is an integer, 5f is a float, 5.2 is by default double, 5.2f is float, 5.2.2 float, this is float. Okay, so you will have to check like what are the possible things you can do. Can I use two method? Can I use f or something else? Okay, all right, now look into this. This does not work. You cannot say, well, x of float is equal to 5.0, because this 5.0 is by default double, and double cannot be converted to float so easily. Okay, if you want to convert, use 2x methods. If you want to convert, use 2 triple x method. That way you can convert this 5.0 to float and then assign it back. Okay, so let me also give you that here. To float, this works. Okay, all right, next. Now if you are trying to do a divisible by 0, in case of your integer division by 0, it will always give you arithmetic exception. Okay, but if you do a divisible, like if you do a float division by 0, then it will always give you positive and negative infinity. Okay, so look into this. Well, x equal to -5 by 0.0. So this is integer, but this is what? Float, right? And then since it is double. Okay, so this is integer and double, right? Now when you try to do this operation, what will happen is this 5 will be converted to double. Okay, and then it becomes double by double. Okay, but in case of your double, if the if you're trying to divide it by 0, then it will always result in infinity. And since you have a minus symbol here, this gives you minus infinity. Okay, so here you're doing double by double, integer by double, right? Here you're doing integer by float. This also gives you minus infinity. Okay, next. No, yeah, that's what. See, this is basically defined by your IEEE some standard. Okay, so this is not related to your Java, or this is not related to your Scala. This is already defined by some standard community that floating divisible should always return you infinities, not arithmetic exception. Okay, so there is some paper on it. You can just have a look on internet. You should basically get the paper of it. But yeah, so whatever programming language you will find, like Java and Scala and all, you'll find that if you're trying to divide by integer, then it gives you arithmetic exception. But if you're trying to divide it by float or double, then it does not give you arithmetic exception. It gives you infinities. Okay, now let's move forward. Expression without assignment. Okay, so see, many times I have been doing something like this, 5 plus 10, right? So what happens is this 5 plus 10 is getting evaluated to 15, and they are assigned to a temporary variable called result 24. Okay, and you can print this result 24, println res24. You can always do that, and it always gives you 15. So whenever you are using this REPL, and then if you are just saying 1, it got assigned to result 26. I say 2, it got assigned to result 27. Now I can say result 26 plus result 27. Okay, so 1 plus 2 equal to 3. It will be again assigned to another result 28. Right? So it is up to you whether you want to really catch it in a variable, or you just want to evaluate it as it is. The advantage of catching it on the variable would be you have a control on the variable names, right? And otherwise, see, this result 27, result 28 will always change, right? So you cannot really give a guarantee that, you know, every time you execute this, you get this values. So I'll always suggest you that whenever you have any expression, try to always catch it in a variable. Okay, but yes, if you're doing it on a REPL for your experiment, then it is absolutely fine. Okay, now if you see this example 5 plus 10, what is happening is 5 is a number, integer by default. This is integer. It has a method called plus, right? So this integer has a method called plus that takes another integer. So this eventually is this, right? This eventually is this 5 object of integer. On it, I'm saying dot, and I'm calling a method called plus. And this plus method takes one parameter called 10. And it returns back one integer called 15. So this 15 is assigned to a variable called res in this case. Okay, you can refer to res later in your program. If you want to print the value again, you can say print of res. But again, as I said, there's no guarantee that you'll always get res1 here, right? Every time when you run the program, it will come up with different values. So I'll not suggest you to do that. Okay, again, if you write the expression again, it gets calculated and gets assigned to next series variable. Oh, 1 minute. Yeah, next series variable res2 or res3 or so on, right? Now see, when you say println, when you do a print, right? So for example, let's take this example, right? So I try to print the value. So currently I'm in 29, right? So I'll say print ln I got 3, right? So I printed that, right? Again, let me say this. So see, 29, and then the next value came 31. Where is the 30? 30 was consumed by this. Okay, can I say print 30? Let's try. When I said print of res30, what did I get? I got unit, because println does not return you anything, and this is the symbol of unit. Okay, whenever your method does not return anything, then if you try to catch the value, you get this empty braces. This empty braces represents unit. Okay, now coming back to double. As you know, by default, every floating value is treated as double unless you don't suffix f or f at the end of the number, right? So for example, this is double. I wrote d, then it became double. If I don't write d, then it will become integer, right? Again, so again, in this example, what I'm doing is I have 5,000 of integer type, which I've assigned it to salary. Done. So my salary is basically an integer type data, right? And now on this salary, I'm saying salary equal to 5,000f. So what is this 5,000? 5,000f is basically a float, which I'm trying to assign it to salary, which is already an integer. Okay, it is defined as variable, so there is no problem with that. But the only problem here is salaries of integer type, and what you're trying to assign is it is a float. So this does not work, right? You cannot assign a float to an integer. Similarly, variable num1 equal to 0.0. So 0.0 is by default double. Okay. Variable number 2 equal to 0.0f. So 0.0f, you have written f. So this is float, right? So 2 e to the power 3, as I told you yesterday, e to the power 3 means 10 to the power. So e to the power 3 means 10 to the power 3. 10 to the power 3 is 1000 into 2 is 2000, right? We were talking this in the range of the float and double, if you remember. Now similarly, variable number 1 equal to 2e2f. So what does it mean? See, when you just say 2e3, then it becomes a double. But if you want to convert them, like if you want to bring a float version of it, then you have to suffix f. E to the power 2 is 100. 100 into 2 is 200. 200f. Okay. Again, if you write variable num1 equal to dot 2, so this is dot 2. So dot 2 means again a decimal thing, and anything which is a decimal is by default a double, unless and until you don't put f here. Okay, clear guys? Any questions still here? Now let's talk about auto typecasting. Okay, let's talk about auto typecasting. So if you are following the below order from left to right, then you really don't need to typecast. Scala takes care of it automatically. Yes, E is always 10. So Scala takes care of it automatically. So this formula is applicable to Java as well. This formula is applicable to Java as well. Okay, so let's look into this. So what I'm trying to tell you is, if you have a byte and if you want to convert it into sort, you don't need a typecast. Sort to integer don't need a typecast. Integer to long does not need a typecast, and so on. Okay, so if you want to see that, what you need to do is, I'll say byte, right? So first you create a byte variable. Well, let's say b is equal to 10.2 byte. So what I got a byte here. I got a byte. Okay, so I have a byte now. Byte to sort. So can I say, well, s of sort is equal to b. Okay, so let's go by this example. See, the first thing what I did is I created a byte variable which is holding 10. Done. Now I'm saying I want to assign this b to a sort. Okay, I want to assign this byte to a sort. So this is allowed. Okay, and you don't really need any typecasting. This is not typecasting anyways, right? So you get 10. Okay, now I want to say this 10, I want to assign it to integer. So again, I'm saying, well, I is equal I of integer type equal to sort. So this sort can be directly assigned to this integer, and again it gets 10. Now this integer can be assigned to a long. So I'm saying, well, L of long type equal to I. So integer is assigned to long. Done. Right? Next, now again, long can be assigned to a float. Long is assigned to a float, 10.0. Float is assigned to a double, 10.0. Right? So if you see, we have gone through in this direction. Byte was assigned to a sort was assigned to int was assigned to long was assigned to float, and float was assigned to double. Okay. Similarly, a character can be assigned to an integer. Well, C of character equal to A. So what I got a character A, and this C, I'm trying to assign it to an integer, 65. Right? So what I'm trying to tell you is, if you want to convert the data from one type to another type, and if they fall in this direction, then you really don't need any typecasting. However, if you want to go against the wind, right? If you want to go against the wind, then you have to do a typecasting. For example, suppose this, look into this. Well, I equal to 10. So what is this? I is integer. I want this integer to be converted into byte. I cannot write like this, right? I cannot be given to a byte directly. Okay, so you'll have to do a typecasting, or you can say .2 byte. Either you use 2 byte or you use as instance of to convert them into the lower data types. Okay, so this concept is called auto conversion, auto typecasting, if you are following in this direction. Okay, now the next one is unit. So unit is basically what? It represents lack of data, which means I don't have data. And it is similar to void in your Java. Okay, so in case of your Java, if you write a method that is not going to return you any parameter, sorry, that is not going to return you any value, then the method signature contains void, right? Similarly, if you're writing a Scala function that does not return any value, then you'll specify the return type as unit. Okay, so the unit literally is a empty pair of parentheses. I was just telling you about this, which is a representation of not having any value. If you want, you can define a value of unit type, but it is basically used in functions and expressions. So see here, well, result equal to this. If you do so, then result becomes a unit type. And this really does not make sense to me, right? So if you are working on functional programming, then you can use this unit to say that my method does not return any value. And that's the reason I used unit. Clear, guys? Any questions?